Hi guys, so basically we learned about Faraday's experiment and Faraday's law. So now we're going to answer and how to determine the directions of induced EMF or induced current. So first of all, we have a Lenz law. Lenz law states that induced current in a loop is always flows in such a direction that is opposed to change producing it. Erti kata lain, according to Lenz law, it doesn't like changes. Dia tak suka perubahan. So dia akan cuba lawan sehabis mungkin supaya there's no changes. So basically Lenz law is an application of conservation of energy. So for example here I have 3 loops. Okay, 3 coils. So this is A, B and C. Okay, as we move from A to B. Okay, so according to the Faraday's law, when there's a changes in magnetic flux, it will be induced EMF or induced current produced. So from A to B, you can see that A, there's no magnetic field around A. Dekat A tak ada magnetic field, tapi bila masuk B, so let's count how many magnetic field lines here. 1, 2, 3, 4, 5 and 6. Means that magnetic field daripada tak ada kepada ada. Daripada kosong kepada 6. Means that there's an increase in magnetic field. Okay, according to the Lenz law, they will be producing induced current that flows such as direction that oppose the changes. What are the changes? The presence of magnetic field. Macam mana nak lawan magnetic field ni? The magnetic field present is into the page. Dia nak jadi kosong. So what dia do is dia akan produce induced magnetic field that oppose masuk. Lawan masuk apa? So going to produce induced magnetic field will be directed out of the page. Produce this is a production lah untuk lawan masuk supaya dia nak maintain tak ada magnetic field. So nak maintain tak ada magnetic field, tiba-tiba ada magnetic field yang masuk, dia akan menghasilkan magnetic field yang keluar supaya they cancel out each other dan jadi tak ada. So this is basically at the moment the changes happen, daripada ada kepada tak ada, A moving to B. Tetapi apabila B maintain saja at the same place for a long time, dia punya current tak akan ada dah. Induced current will not be produced because there's no changes in magnetic flux. Okay, so kalau kita kata tadi A pergi B, what happen if B goes to A? B move to A. So what happen when B move to A? Kita ada tadi, wait, I'm just going to padam ni jap. Okay, bila B pergi A, at B there are 6 magnetic field lines. Okay, so dekat A tu tak ada magnetic field kan? A ni empty, there's no magnetic field. So according to Lenz law, they're going to produce induced magnetic field to oppose the changes. So apa perubahan yang berlaku sekarang? Mula-mula ada magnetic field 6 masuk into the page, tiba-tiba tak ada. So according to Lenz law, dia akan produce induced magnetic field going into the page supaya there's no changes. Okay, B and C. What happens is when B moves to C. So okay, here, so first of all kita ada 6 dekat sini. Dekat C kita ada berapa? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. For example, 17. Okay, 17 magnetic lines that passes through an area for 17 Weber lah. Okay, so basically dia nak maintain, according to Lenz law, dia nak maintain apa? Dia nak maintain 6 magnetic field lines sahaja. So now there's 17. So gonna happen there is dia akan produce induced magnetic field untuk cancelkan another 11. So 3, 4, 5, 6, 7, 8, 9, 10, 11. So yang tinggal sekarang hanyalah, saya ingat masa tak tadi, 1, 2, 3, 4, 5, ambil ni tadi, 6. Okay, so bila dia producekan induced magnetic field going out of the page, so you're going to cancel out these magnetic fields. So the only things left here will be 6 magnetic field, same as position B. Okay, so this is a Lenz law flow chart, how to determine the directions of induced current in the conducting loop. Okay, so first of all, we need to determine the directions of external magnetic field in the loop. This will be given in the questions. You mesti akan ada dalam soalan external magnetic field, means that in the question, what is the original directions of magnetic field? Okay, so this first of all, we're going to determine the external magnetic field. Okay, then we're going to check whether there's a changes in magnetic flux ataupun tidak. Okay, by definition, sama ada flux increase ataupun tidak. Okay, if the answer is no, when there's no changes in magnetic flux, dia dah duduk dekat situ lama-lama, flux dia sama sahaja for a long time, means that there's no induced current. Okay, next, if it's yes, then you got to check whether it's increasing or decreasing. Okay, look at here. If it's decreasing, magnetic flux is decreasing. What's going to happen is, loop going to create induced magnetic field through is centered in the same direction as the external magnetic field, so as to replace the loss of the external magnetic field. So basically, if the changes in magnetic field is decreasing, magnetic flux is decreasing, means that induced magnetic field produced will be in the same direction as the external magnetic field. So then kita akan guna right hand gate rule yang kedua to find the directions of induced current. So if the magnetic flux is happen to increase, so induced magnetic field will be in opposite direction of the external magnetic field to cancel the increase in the external magnetic field. Okay, dan kita akan guna right hand gate rule yang kedua to find the directions of induced current. Okay, contohnya macam tadi kan, I give you examples already. Okay, so you can see here from A to B. Okay, from the Lenz law punya flowchart, first we need to determine the directions of external magnetic field. As I said, it will be given in the question. So what is the directions of magnetic field present in the question? Nampak tak? So it will be X. So X is into the page, means that B external is into the page. Okay. For example, if we want to make it A to B, okay, A is moving to the B. So what you can see here, what happened to magnetic flux? So from there's no magnetic field lines, the magnetic flux now we're going to increase. Daripada tak ada magnetic field line kosong, magnetic field line yang passes through dah jadi dah 4. Inside the flux will increase. So second step for A to B adalah the changes in flux will increase. Okay, when the changes of flux is increasing, so we're going to produce the induced magnetic field. Induced magnetic field are going to change, oppose the changes. Oppose the changes which will be in opposite direction, as I said before. So now daripada tak ada kepada ada, so ada pun into the page. Untuk cancelkan into the page, the B induced produce going to be out of the page like that. So B induced will be out of the page. Okay, so according to the Lenz law, induced magnetic field lines will be produced out of the page to cancel the change in magnetic flux. So the third step is to determine the directions of induced current. Kita akan guna right hand grip rule. So kita punya B induced kita tadi keluar. So right hand grip rule, kita akan dapat you punya directions of I induced adalah anti-clockwise. So that will be the step. Dekat mana kita nak sebut pasal Lenz law is here. Lenz law is applicable here lah. Okay, what happen if it's moving from B to C? Tadi A pergi B, so now we are moving B pergi C. Okay, B external masih lagi sama, which is into the page. So what happen is moving from B to C. You can see here, initially there are magnetic flux. But then when it's moving to the C, dia dekat kawasan yang tak ada magnetic field lines, so dia punya flux pun dah berkurangan. So in the changes, in other words, the changes in magnetic flux awak akan decreasing. Okay, bila decrease, what does this mean by it's decreasing? So dia akan menghasilkan B induced magnetic field that is in the same direction as external magnetic field, which is into the page. Awak kena ingat satu benda, yang Lenz law doesn't like changes. So initially dia ada 4 magnetic field lines, lepas tu tiba-tiba tak ada. So according to the Lenz law, dia akan produce dekat sini sama juga induced magnetic field line yang sama direction dengan external magnetic field. Sebab dia tak nak jadi tak ada, dia nak ada juga, nak ada sama macam before, tak nak berubah. Lepas tu tantrum sekarang. So apa yang jadi, dia akan menghasilkan induced magnetic field line into the page macam ni. Therefore kita akan guna right hand grip rule, okay, untuk producekan I induced current. In what direction? Your thumb will be directions of B induced. So dia akan pusingkan, akan dapat clockwise of induced